What if the stars themselves were whispering a warning, not from some distant galaxy, but from the shadows of our own world? Picture this: a shimmering streak slicing through the velvet black of night. Not just any comet, but one hurtling from the endless void between stars, carrying secrets that could shatter everything we think we know. This is no ordinary visitor. It's 3I Atlas, our third confirmed interstellar wanderer. And its arrival feels almost too perfectly timed, like a script written by unseen hands. As it awakens under our sun's glow, releasing gases in patterns that defy easy explanation, whispers spread across the globe. Could this be the dawn of Project Bluebeam, that infamous blueprint from the 1990s, where illusions in the sky convince humanity to kneel before a fabricated new order? Let me draw you deeper into this cosmic enigma. Dear listeners of Cosmic Mysteries for Sleep, I'm Zen, your guide through the tranquil yet thrilling unknowns of the universe, where wonder meets the edge of what might be possible. This comet, discovered on the 1st of July in 2025 by the vigilant eyes of the Atlas telescope in Chile's vast deserts, isn't just a frozen rock tumbling through space. It's a messenger from alien solar systems, bearing chemical fingerprints that astronomers are still unraveling unusually high levels of carbon dioxide compared to water, strange ways its dust scatters light, and a trajectory that screams, "Not from here." But here's the twist that keeps me gazing upward long into the night. It arrives right as stories of sky deceptions reach a fever pitch, echoing Serge Monast's warnings from decades ago about holographic spectacles designed to mimic divine events or cosmic threats. As we embark on this journey together, feel the gentle pull of curiosity, like a soft breeze carrying you toward revelation. Project Bluebeam, for those new to its lore, was Monast's claim of a grand deception, a plan to project false gods or alien invasions into the heavens, using advanced tech to unite the world under one rule, promising safety from imagined perils. Dismissed by many as wild fantasy, it lingers because, well, haven't we all seen those drone light shows that paint the sky with impossible shapes? Or videos online that blur the line between real and rendered? Now, with 3I Atlas streaking closer, its tail growing like a luminous banner, some wonder if this is the test run, a real celestial event woven into the myth to gauge our reactions. But hold that thought, and let's ground ourselves in the awe of what's truly happening. This comet, officially dubbed 3I Atlas or C2025N1, marks only the third time we've confirmed an object from beyond our solar system gracing our skies. The first was Oumuamua in 2017, that enigmatic cigar-shaped scout that sped away before we could fully grasp it. Then Borisov in 2019, more like a classic comet with its familiar icy outbursts. Now, 3I Atlas bridges them, exotic yet awakening in ways we can study in real time. Its path is hyperbolic, meaning it won't loop back. It's a one-way traveler, slingshotting around our sun at speeds that would make any spacecraft jealous, about 40 kilometers per second. As it nears its closest point to the sun on the 29th or 30th of October this year, it'll be about 1.36 to 1.4 astronomical units away, inside Mars's orbit, but safely distant from us. What makes my heart race, in that quiet, contemplative way, is how this visitor's quirks align so eerily with the old theories. Its chemical makeup, revealed by the James Webb Space Telescope on the 6th of August just last month, shows carbon dioxide dominating over water 8 times more, in fact, which is rare for comets born in our neighborhood, but hints at birth under a different star's harsh conditions. And the polarization of its light, extreme and negative, suggesting dust particles with unusual properties, almost like they're engineered to reflect in ways that catch the eye. Coincidence? Or something more? Official astronomers from NASA and the European Space Agency track it meticulously, assuring us there's no deviation from natural physics, no threat, as it passes Earth in December at a comfortable 270 million kilometers, roughly 700 times the Moon's distance. Yet, the intrigue builds because we're living in a time when every unusual glow in the sky sparks debate. Remember those synchronized drone displays at the 2018 Winter Olympics, where over 1,000 lights danced in perfect harmony? They prove we can create sky art that fools the senses. So, what if 3i Atlas is the ultimate illusion? A holographic projection testing our gullibility, as blue beam theorists suggest? Or perhaps it's genuine, a frozen ambassador carrying clues about how planets form far away, and the real mystery is why our minds leap to deception so readily. As I share these thoughts with you tonight, nestled in whatever cozy corner of the world you're in, perhaps under a blanket in a quiet room or drifting off in a hammock beneath the stars, I can't help but feel connected to this vast puzzle. If this tale resonates, why not hit that like button to let the universe know you're along for the ride? Subscribe to Cosmic Mysteries for Sleep for more serene explorations like this, and drop a comment below with where you're listening from and what time it is there. Think of it as sending a postcard from your spot in the cosmos, sharing the magic with fellow dreamers. It keeps our community glowing, just like that comet's tail. Now, back to the heart of our story, where science and speculation entwine like vines in a midnight garden. The discovery itself unfolded like a dream sequence. On that July day in 2025, the Atlas system, designed to spot Earth-threatening asteroids, flagged a faint mover against the stars. Within 24 hours, calculations confirmed its interstellar origins, a rarity that astronomers call a cosmic lottery win. We've scanned the skies for decades with ever sharper telescopes, yet only 3 such visitors have shown up in the last 8 years. Each one peels back layers of the galaxy's hidden life, revealing rogue comets ejected from distant systems by gravitational tugs or stellar explosions. 3i Atlas stands out because it's already active. Its coma, that fuzzy halo of gas and dust, expanding as solar heat sublimates its ices. By autumn, as we approach now on this 10th of September in 2025, it's developing a tail that could stretch millions of kilometers, pushed by solar winds. But the timing, the timing fuels the fire. We're in an era of heightened whispers about unidentified aerial phenomena, government disclosures on unexplained sightings, and social media algorithms that amplify every blurry video into proof of something sinister. Is it mere chance that this comet arrives when blue beam tails are viral again? Or is there a synchronicity begging exploration? To add to the allure, let's weave in a personal thread from my own stargazing days. Years ago, as a young seeker of serenity, I lay on a hilltop during a meteor shower, feeling the universe's pulse for the first time. That night, a streak much like this comet crossed my view, sparking questions that led me here, sharing these mysteries with you. It's reminiscent of films like Arrival, where an otherworldly visitor forces humanity to confront the unknown not with fear, but with profound connection. 3i Atlas evokes that same vibe, a real entity, studied by teams in Chile, Hawaii, and beyond, yet sparking imaginings of probes hidden in its nucleus or illusions beamed from satellites. As we prepare to dive deeper in the hours ahead, know that our path will balance the scales, honoring the hard data from observatories, while acknowledging the human pull toward the fantastic. We'll trace Blue Beam's origins, revisit past interstellar guests, and examine what telescopes reveal about this comet's inner workings. No panic, just peaceful inquiry, perfect for unwinding into sleep. But for now, let the hook sink in. What if this comet isn't just passing through, but inviting us to question the boundary between sky and stage, reality and ruse? Stay with me, and let's uncover the truth together, one starry revelation at a time. The questions multiply as we consider the comet's Mars encounter on the 3rd of October, brushing within 28 million kilometers close in cosmic terms. Yet routine mechanics, spacecraft around the red planet might glimpse it, adding layers to our understanding. Meanwhile, back on Earth, forums buzz with theories. Is the unusual dust behavior a sign of mini-probes detaching, as some speculative papers suggest, or simply natural grains from an alien frost line? The beauty lies in the blend solid science, confirming its safe, predictable path, intertwined with the thrill of what-ifs that make nights like this unforgettable. And as the comet hurtles on, its story mirrors our own quest for meaning in the dark. We've come far in just these opening moments, from the initial shock of its arrival to the gentle reassurance of ongoing monitoring. But the adventure is just beginning, promising hours of serene discovery. If you're feeling that spark, remember to like, subscribe, and comment your location and time. It's like collecting cosmic postcards that connect us all under the same sky. Now, let's ease into the next layer, where the comet's journey truly unfolds. As we turn our gaze to the path this enigmatic traveler has carved through the cosmos, let's follow 3I Atlas on its epic voyage, a silent wanderer born under a foreign star, now racing through our solar neighborhood with secrets locked in its icy core. This comet, plucked from the interstellar depths, isn't just drifting aimlessly. It's hurtling along a hyperbolic curve, a mathematical arc that defies the sun's full grasp, proving without doubt that it hails from beyond our familiar bounds. Imagine the sheer audacity of such a journey, ejected perhaps by a gravitational tussle in a distant stellar nursery, or flung free during a cataclysmic event like a supernova's blast. It has traversed the galaxy's empty expanses for millions, maybe billions of years, enduring temperatures mere degrees above absolute zero. Its surface, a frozen archive of cosmic history. What draws us in, what sparks that quiet thrill in the chest, is how this visitor announces itself not with fanfare, but through the subtle language of physics. Its speed alone tells a tale of origins far removed, clocking in at over 150,000 miles per hour, or roughly 67 kilometers per second. It's moving with the kind of velocity that only interstellar refugees possess. This isn't the leisurely orbit of our local comets, bound eternally to the sun's embrace. No, 3I Atlas is unbound, a one-time guest slinging past our star, on a trajectory that will fling it back into the galactic wilderness after a brief, brilliant flirtation with warmth. Discovered on the 1st of July in 2025 by the Atlas Survey Telescope nestled in Chile's arid highlands, it was flagged as an anomaly. Almost immediately, a faint speck shifting against the starry backdrop, its motion betraying a path that screamed outsider. Delving deeper into its mechanics, astronomers pieced together the puzzle within days. By the 2nd of July, the Minor Planet Center had dual-tagged it, 3I for its status as our third confirmed interstellar interloper, and C 2025 N1 to highlight its cometary nature, spotted in the first half of the year. This naming isn't mere bureaucracy. It's a nod to its split personality, part alien artifact from unknown realms, part familiar icy body responding to our sun's gentle prodding. As it barrels inward, the sun's heat begins its transformative work, sublimating, that's the scientific term for turning solid ice straight to gas, the comet's volatiles, creating that ethereal coma a hazy envelope of released materials that shrouds the nucleus like a mystical veil. And then comes the tail. Oh, the tail. A streaming banner of dust and gas pushed outward by solar radiation pressure, stretching potentially millions of kilometers. A luminous flag waving farewell to the void it left behind. But let's pause here. Breathe deeply. And let your mind expand with the scale of it all. Inhale slowly, feeling the vastness. Exhale, releasing any tension as you envision the sun's rays, like fingers of light, coaxing life from this dormant giant. It's akin to awakening a long slumbering soul, where frozen ices, water, carbon dioxide, carbon monoxide begin to stir, revealing clues about the comet's birthplace. Recent glimpses from the James Webb Space Telescope, captured on the 6th of August in 2025, paint a portrait of chemical intrigue, a dominance of carbon dioxide over water, with ratios around 8:1, far higher than most comets we've known from our own solar backyard. This isn't just data. It's a whisper from another world's formation, suggesting 3I Atlas coalesced in a colder, more carbon-rich environment, perhaps around a star with different chemistry, or in a nebula laced with exotic elements. Add to that the detection of carbonyl sulfide, water ice, and various dust grains, and you have a chemical treasure chest, each molecule a breadcrumb leading back to processes billions of years old. Comparing this to its predecessors adds layers of fascination, like uncovering chapters in a galactic saga. Recall Oumuamua, that first interstellar scout from 2017, elongated like a cosmic cigar, tumbling with an 11-hour spin, and accelerating mysteriously without visible outgassing, sparking debates about natural jets, or even artificial sails propelled by starlight. Avi Loeb's bold hypothesis lingers in the air. Could it have been a probe from elsewhere? Then there's Borisov in 2019, more conventional, with its water-heavy composition and dramatic fragmentation observed by Hubble, splitting like a cosmic egg to reveal inner layers. 3I Atlas bridges them beautifully larger than both, estimated at about 7 miles wide, based on fresh images from the Vera C. Rubin Observatory in July 2025, making it the biggest interstellar object we've eyed yet. Unlike Oumuamua's stealthy exit or Borisov's predictable fizz, this one offers a front-row seat to its evolution, its coma expanding rapidly since late summer, hinting at a nucleus heterogeneous and layered, perhaps with pockets of volatiles waiting to burst forth. The timeline ahead promises peaks of drama, timed by the inexorable pull of gravity. As autumn deepens here on the 10th of September in 2025, 3I Atlas is already brightening, its activity ramping up. As it closes in on perihelion, the point of closest approach to the Sun, slated for the 29th or 30th of October. At that moment, it'll dip to about 1.36 to 1.4 astronomical units from our star, inside Mars's orbital lane but comfortably outside Earth's, positioning it for maximum solar baking. Frustratingly poetic, though. During this climax, the comet will lurk on the Sun's far side from our viewpoint, veiled by glare, like a performer slipping behind the curtain at the height of the show. But patience rewards the watchful. By December, it emerges, grazing closest to Earth at roughly 1.8 astronomical units, or 270 million kilometers, far enough to pose zero risk, yet near enough for our sharpest instruments to pry deeper. Intrigue mounts with its brush past Mars on the 3rd of October, swinging within 28 million kilometers of the red planet. That's about 75 times the Earth-Moon gap. Routine in the grand scheme, but imagine the possibilities. Orbiting spacecraft like those from NASA's fleet might snag opportunistic snapshots, comparing Martian dust interactions, or even sniffing for chemical exchanges. This flyby isn't just a checkpoint. It's a chance to probe comparative planetology, seeing how an alien ice body reacts to a world unlike its own. And here's where curiosity tugs stronger. Early polarization measurements show extreme negative behavior, meaning the way light bounces off its dust is unusually pronounced, suggesting grains with peculiar sizes or textures. Could this be a hint of formation in a high radiation stellar cradle, or something more enigmatic, like embedded materials from a planetary collision eons ago? Tracing its origins backward through orbital math reveals even more allure. Calculations suggest it approached from the constellation Lynx, a direction hinting at a long meander through the Milky Way's disk, perhaps nudged by passing stars or black holes' subtle influences. Forward projections show it departing towards sextans, carrying a souvenir of our sun's radiation back into the dark. This isn't random. It's part of the galaxy's slow exchange program, where systems swap debris over immense timescales, building a cosmic web of shared history. With improved surveys like those from Pan-STARRS or the upcoming Legacy Survey of Space and Time, we're spotting these wanderers more frequently. 3 and 8 years implies a hidden population vast beyond counting, rogue worlds and comets adrift, waiting to teach us about the universe's untamed frontiers. Yet, the real captivation lies in what 3i Atlas might unveil about life itself. Its ices, preserved through the interstellar chill, could harbor organic compounds, precursors to biology formed in alien conditions. Spectroscopic peaks from Swift's ultraviolet eyes have already spotted hydroxyl emissions, water molecules shattered by solar UV earlier and farther out than expected, confirming robust water activity. Combine that with the carbon monoxide and sulfide traces, and you have a recipe for astrobiological speculation. Did this comet seed distant worlds with the building blocks of existence? Or does it carry echoes of failed planets from its home system? As it awakens fully, ground-based scopes in Hawaii and Chile, alongside space sentinels like Hubble, are mobilizing for a symphony of observations, each data point a note in unraveling these riddles. The comet's size adds to the spectacle, 7 miles across, dwarfing Oumuamua's modest football field length and Borisov's few-kilometer span. This bulk means more material to study, potentially sustaining outgassing for months, allowing us to watch its internal structure evolve. Fragmentation, like Borisov's dramatic split, isn't out of the question. Thermal stresses could crack it open, exposing fresh layers for analysis. And the dust properties from polarimetry intrigue endlessly, with grains possibly fluffy or porous, scattering light in ways that challenge models of solar system comets. It's as if 3i Atlas is a time capsule, its contents narrating tales of stellar birth pangs, disk instabilities, and the chaotic dance that forms worlds. As our exploration of this journey winds toward its close for now, I find myself wondering about you, out there in the quiet of your evening, or the hush of dawn. Where in the world are you tuning in from tonight? And what hour marks the sky above you? Perhaps the witching hour in a bustling city, or the soft light of early morning in a serene countryside. Share in the comments below. It's like mapping our own interstellar connections, one listener at a time. Shifting our focus now to the shadowy blueprint that has captivated minds for decades. Let's uncover the intricate design of Project Blue Beam, a theory that weaves deception into the fabric of the heavens themselves. Born from the revelations of Canadian journalist Serge Monist in the early 1990s, this concept emerged not as a mere rumor, but as a detailed accusation against hidden powers, NASA, the United Nations, and elusive global elites plotting to orchestrate the ultimate illusion. Monist, a dedicated investigator into the occult and government secrets, claimed to have pieced together leaked documents and insider whispers painting a picture of a multi-phase operation aimed at dismantling religions, erasing borders, and installing a singular world government under the guise of salvation from cosmic catastrophe. His warnings, published in pamphlets and shared through underground networks, warned that technology would be weaponized to manipulate the masses on a planetary scale, turning the sky into a canvas for fabricated miracles and terrors. What fuels the enduring fascination with this theory is its chilling plausibility in an era where advancements blur the line between reality and artifice. Monast outlined 4 escalating stages, each building on the last-like chapters in a dystopian novel, designed to exploit humanity's deepest fears and hopes. The first phase, he alleged, involves engineering artificial disasters, earthquakes, floods, or archaeological discoveries unearthed by these events to undermine established faiths. Picture orchestrated tremors revealing ancient artifacts that contradict sacred texts, sowing doubt in billions of believers overnight. Monast suggested this would be achieved through classified seismic weapons or directed energy devices, tools that, even in his time, were whispered about in military circles. Fast forward to today, on this 10th of September in 2025, and we see echoes in real-world events. Mysterious drone swarms over New Jersey and other states late last year, which conspiracy circles linked directly to Bluebeam rehearsals, as reported by outlets like Newsweek and NBC News. Those sightings, unexplained and numbering in the hundreds, prompted figures like Alex Jones and Trump allies to cry foul, suggesting they were tests for creating widespread panic. Building on that foundation of doubt, the second phase escalates to the spectacular. Massive holographic projections beamed into the atmosphere, manifesting as religious icons tailored to each culture. Jesus appearing over Christian lands, Buddha in the East, Muhammad in Islamic regions, all speaking in unison, fulfilling prophecies while actually scripting them. Monast described laser systems ionizing air particles to form 3-dimensional images visible across continents, synchronized with audio manipulations to make the vision speak directly to observers. This isn't pure fantasy. Consider the record-breaking drone show at the 2018 Winter Olympics, where 1,218 synchronized drones formed intricate patterns in the night sky, dazzling millions. Intel's feat proved coordinated aerial displays are feasible, and by 2024, similar technologies evolved amid those East Coast drone mysteries, which some theorists, including podcasters on Bleav's Triple T podcast in April 2025, tied to Bluebeam's holographic trials. Even a striking light formation over Alabama on the 12th of July this year resembled biblical apparitions, fueling online debates about plasma-based projections, experimental tech that manipulates ionized gas to create glowing shapes, as discussed in declassified military papers. The theory deepens in the third phase with synthetic telepathy, where electromagnetic waves allegedly implant thoughts, voices, or visions into minds, making the holograms seem divinely personal. Monast pointed to mind control research like MKUltra's successors, claiming low-frequency signals could bypass reason, whispering commands from the gods above. In our current landscape, this resonates with advancements in neural interfaces, devices like Neuralink, which by 2025 have progressed to basic thought-reading trials, raising ethical alarms. Yet, theorists on platforms like X, formerly Twitter, connect it to recent events. Posts from users like The Foiled on the 8th of September speculate that Comet 3i Atlas's unusual signals might be cover for such tech, with its polarization quirks, mimicking interference patterns from voice to skull experiments. A channeled message from Ashtar Command, shared widely on X in late July and early August, warns of psychological operations using the comet as a focal point, urging discernment against implanted fears. These updates, including a YouTube video by Demcad titled 3i Atlas, Comet, Alien Ship, or Project Blue Beam, viewed thousands of times, blend Monast's blueprint with 2025's headlines, suggesting the phase is already in soft rollout through social media psyops. Culminating in the fourth phase, the projections and voices unite to proclaim a new messiah, dissolving old religions and nations into a totalitarian order. Monast envisioned a false savior emerging from the chaos, backed by the illusions, to enforce global compliance. This endgame, he argued, would erase individual freedoms under the banner of unity against cosmic dangers. Distinguishing this from historical investigations like Project Blue Book, the real US Air Force UFO probe from 1952 to 1969, which documented thousands of sightings through rational lenses. Blue Beam thrives in speculation's shadows. Blue Book yielded unexplained cases, but no grand conspiracy. Blue Beam, conversely, morphs with each era, incorporating aliens, climate hoaxes, and pandemics. By 2024, as drone sightings escalated, influencers like Charlie Kirk tied them to Blue Beam's final push, per North Jersey.com reports. While Times of India articles in December linked MAGA theories to staged invasions for control, a script document outlining the phases, still circulating, mirrors Monast's original, but 2025 editions like the Alabama Lights on Facebook suggest evolving tactics, perhaps using AI-generated deepfakes to simulate messianic figures. This adaptability explains Blue Beam's grip. It mirrors human anxieties about power, technology, and the unknown, evolving from Monast's religious focus to encompass modern perils. In 2025, with Comet 3i Atlas dominating astronomy news, its 7-mile nucleus imaged by Hubble on the 7th of August, per NASA speculation, surges. Threads from users like Antebellum and Early PFC question if the comet's tail, developing since discovery on the 1st of July, is a holographic test, echoing Monast's sky illusions. A detailed Ashtar channeling, posted by Nettie on the 1st of August, frames the comet as a cabal distraction for a false flag invasion, weaving in quantum financial systems and elite lists as motives. This post, with its urgent warnings of martial law and weaponized space, garnered likes and reposts, blending conspiracy with spiritual lingo to heighten curiosity. Yet, probing deeper reveals the theory's core vulnerability, its reliance on unproven tech at impossible scales. While drones like those in 2018's Olympics create localized wonders, continental holograms demand energy grids beyond current feasibility. Laser arrays, ionizing vast atmospheres would require power plants rivaling nations. Plasma manipulation, tested in labs for small displays, falters outdoors against wind and weather. Neuroscience advances synthetic telepathy in controlled settings, but broadcasting to billions defies physics, as electromagnetic fields weaken over distance. Monast's claims, lacking concrete evidence, persist through pattern-seeking brains, a psychological quirk where unrelated events like drone swarms and comet arrivals forge connections. Recent updates, such as NDTV's December 2024, piece on US, drones tied to Blue Beam, highlight this. Sightings near military sites sparked theories of elite orchestration, yet official probes found no threats per NBC. Linking back to 3i Atlas, the comet's real traits high carbon dioxide ratios from James Webb data. Mars-flyby on the 3rd of October fuel. Blue Beam whispers on X. Posts from Moshe Christ on the 26th of August urge baseline energy against voice to Skulltech, while Violet Chan's YouTube share on the 31st of July echoes Ashtar's alert, portraying the comet as a psyop trigger. A Facebook post on the 17th of July about Alabama lights resembles celestial puppet shows, per Monast. These 2025 developments suggest the theory's mutation, from 90s holograms to AI-augmented deceptions, incorporating UAP disclosures in congressional hearings. Theorists argue transparency is the ploy amid real sightings to blend with fakes. Yet astronomers counter with verifiable data, like NASA's animation of the comet's path, confirming no deviation. This interplay keeps the mystery alive, prompting questions: why do drone theories from 2024 resurface with a 2025 comet? Per Yahoo's December article, Blue Beam posits abolishing Abrahamic religions via staged events, aligning with Ashtar's warnings of religious holograms. A Belief podcast on the 15th of April dissected if Blue Beam heralds world's end, tying to financial crashes as diversions. YouTube videos like Mass Drone Sightings, part of Project Blue Beam, from December 2024, speculate Iranian motherships off US coasts, but 2025 shifts focus to Atlas. As Space.com notes, its Mars approach sparks scramble for observations, perhaps cover for monitoring threats. Delving into psychology, Blue Beam endures as a comprehensive narrative explaining chaos, from pandemics to elections. It appeals to those sensing institutional betrayal, offering villains in a confusing world. Monast's death in 1996, under suspicious circumstances, adds martyrdom, fueling beliefs of suppression. In 2025, with Atlas's perihelion nearing the 29th of October, ex-user Bataros, on the 26th of August, queries Comet alien links, while Tina Frisco's post reassures it's natural, debunking scares. This tension between NASA's science and conspiracy's allure mirrors Monast's blueprint. Use real events like comets to seed doubt. Technology's role can't be overstated. Monast foresaw lasers and computers rendering divine figures, now echoed in RD-Kit chemistry sims or PySCF for plasma models. But scaling remains fictional. Olympics drones were terrestrial, not atmospheric giants. Laser weapons, declassified in 2024, create effects but not continent-spanning visions. Blue Beam's danger, as 2025 podcasters note, lies in eroding trust. If skies deceive, what remains real? Yet, linking to Atlas, its dust properties suggesting alien origins, per Wikipedia, invites wonder. Is the comet's CO2 dominance natural, or a narrative hook? As theories evolve, incorporating quantum finance or elite lists from Ashtar posts, Blue Beam becomes a flexible lens. 2025's Alabama formation, per Facebook, resembled gods, tying to Phase 2. Drone conspiracies from Trump allies, per North Jersey, suggest preparation for Phase 4's order. Ultimately, Monast's legacy probes human nature. Why crave grand deceptions? In Atlas's context, its safe trajectory debunks threats. Yet curiosity lingers. What if the blueprint unfolds? Using the comet as prop, this dance of doubt and discovery keeps us peering skyward, questioning every light. Before we fully embrace the enigma of Three-Eye Atlas, let's journey back to the trailblazers that paved its way, the pioneering interstellar visitors that first shattered our assumptions about the cosmos and ignited debates that still echo today. These aren't just distant specks in the sky. They're harbingers of a larger galactic narrative, each with quirks that challenge what we thought possible, drawing us into a web of wonder where science meets the edge of speculation. Our story begins with One-Eye Oumuamua, the Hawaiian-named scout that burst onto the scene in 2017, forever changing how we scan the heavens for outsiders. Detected on the 19th of October that year, by the Pan-STARRS telescope in Hawaii, Oumuamua wasn't initially flagged as extraordinary, just another moving dot amid the stars. But as data poured in, its hyperbolic path revealed the truth. This was no local asteroid or comet bound to our Sunday. It had come from elsewhere, racing in at over 87,000 miles per hour, too fast to be captured by our star's gravity. Measuring roughly 800 feet long, but only about 115 feet wide, it tumbled end over end every 8 hours, its elongated shape evoking images of a cosmic cigar or flattened pancake, unlike anything in our solar system's inventory. What truly set pulses racing was its subtle acceleration as it departed no visible tail or coma. Yet it sped up as if propelled by invisible forces. Astronomers puzzled over this. Was it outgassing from exotic ices like molecular hydrogen, too faint for our scopes to catch? Or something more exotic, like radiation pressure on a thin, sail-like structure? This anomaly sparked one of astronomy's most lively debates, with Harvard's Avi Loeb proposing in 2018 that Oumuamua might be artificial, a light sail from an advanced civilization, perhaps a derelict probe scouting systems like ours. His book, Extraterrestrial, in 2021, amplified the idea, suggesting its flat profile and lack of volatiles fit tech rather than nature. Critics countered with natural explanations, perhaps a fragment from a disrupted planet, or nitrogen ice evaporating subtly, as a 2021 Nature study suggested. By 2023, further models in the astrophysical journal Letters leaned toward hydrogen ice, formed in cold molecular clouds, explaining the push without detectable gas. Yet, in 2025, fresh analyses revisit this. A preprint on ArgSci from July, inspired by 3i Atlas's data, re-examines Oumuamua's light curve, hinting its spin might indicate internal fractures from interstellar radiation bombardment over eons. Imagine it, a battered survivor of galactic perils, its surface scarred by cosmic rays, carrying stories of violent births in distant stellar nurseries. Oumuamua's brief visit, discovered post-perihelion, already outbound, left us with tantalizing glimpses, but unanswered riddles. It faded beyond Hubble's reach by early 2018, a cosmic tease that underscored our need for faster response teams. The object's reddish hue, from long exposure to interstellar radiation, matched expectations for aged spacefarers. But its lack of water or carbon signals puzzled, suggesting formation far from any warm star. In 2024, simulations using data from the Vera Sea, Rubin Observatory's precursors, modelled similar objects, predicting thousands lurk undetected, ejected from young systems by giant planets' gravitational games. Fast forward to 2025, and Oumuamua's legacy informs 3i Atlas studies. Both show non-gravitational nudges, but where Oumuamua hid its secrets, Atlas reveals them openly, its carbon dioxide dominance echoing possible volatile mixes. Oumuamua might have harboured if we'd caught it sooner. Shifting to our second interstellar guest, 2i Borisov arrived in 2019, like a more welcoming cousin, discovered not by billion-dollar machines, but by amateur astronomer Gennady Borisov on the 30th of August using a homemade telescope in Crimea. This personal touch added charm proof that backyard stargazers can rewrite history. Unlike Oumuamua's stealth, Borisov announced itself boldly, a classic comet with a developing coma and tail, brightening as solar heat thawed its ices. Roughly 3 miles across, it followed a hyperbolic arc, inbound at 110,000 miles per hour, its path tracing back toward the constellation Cassiopeia, possibly from a red dwarf system like Kruger 60, as 2020 models in astronomy and astrophysics suggested. Borisov's chemistry offered the first taste of alien worlds. Spectra from Hubble and ground scopes like Very Large Telescope revealed water vapor, carbon monoxide at unusually high ratios, 26 times more than water, per a 2020 Nature Astronomy paper, and traces of cyanide, diatomic carbon, and ammonia. This mix differed from our Oort cloud comets, hinting at formation in a carbon-rich environment, perhaps nearer its star's frost line. Then came the drama. By December 2019, Hubble spotted fragmentation, the nucleus splitting into at least 2 pieces, likely from thermal stress or rotational forces, exposing fresh interiors for study. This breakup, detailed in 2021's Icarus Journal, revealed layered structure, with dust-to-gas ratios skewing toward more dust, suggesting evolutionary differences from solar system bodies. In 2022, further analysis via ALMA radio telescope detected molecular species like hydrogen, cyanide, and formamide, organics tied to prebiotic chemistry, sparking astrobiology buzz. Could interstellar comets seed life across galaxies? By 2024, machine learning reprocessed Borisov's data, uncovering subtle asymmetries in its tail, possibly from uneven outgassing, as a MNRAS study noted. Now, in 2025, Borisov's echoes resonate with 3I Atlas. Both comets show carbon monoxide prominence, but Atlas's carbon dioxide lead flips the script, prompting comparisons in August's Astrophysical Journal preprints. Borisov's conventional behavior, predictable sublimation matching models, contrasts Oumuamua's mysteries, teaching us interstellar objects vary wildly, from rocky enigmas to icy spectacles. These predecessors highlight patterns. Oumuamua's ambiguity fueled alien tech theories, with Loeb's 2025 op-ed in Scientific American revisiting it amid Atlas's arrival, pondering if such objects are probes. Borisov, more textbook, demonstrated amateur contributions and rapid campaigns, mobilizing over a dozen observatories within weeks. Both underscored time's cruelty. Oumuamua escaped scrutiny. Borisov allowed months of data before fading in 2020. In 2025, this informs Atlas pursuits. Enhanced networks like those from ESA's Comet interceptor, proposed in 2019 and launching next decade, aim to rendezvous with future visitors, per a July 2025 ESA update. Oumuamua and Borisov also reveal human elements. Oumuamua's name honors Hawaiian culture. Borisov's credits a hobbyist, democratizing discovery. 2025 studies, like a planetary science journal piece, estimate interstellar flux 1 per year detectable, with upcoming surveys like LSST starting 2025. This predicts a boom, with Atlas as harbinger. Oumuamua's non-gravitational force, now modeled as solar radiation on asymmetric surfaces in a 2024 AppJ paper, parallels potential Atlas behaviors. Borisov's fragmentation warns of Atlas's perihelion risks on October 29th. Diving into specifics, Oumuamua's 2017 light variations brightening by factor of 10 suggested extreme elongation, ratio 10:1, defying natural formation odds without tidal disruption, as 2019 simulations showed. 2025 reanalysis with AI from MIT's ArgZiv post in June refines this to possible disk shape, like a flattened shard from a hypervelocity impact. Borisov's 2019 spectra, re-examined in 2024's ACS Earth and Space Chemistry, confirm alien organics, with deuterium ratios hinting at cold birth, differing from solar nebula. These objects bridge to Atlas. Oumuamua's elusiveness contrasts Atlas's visibility through September 2025 per NASA. Borisov's water detection via hydroxyl, like Atlas's SWIFT data, links them chemically. 2025 news, like EarthSky's August 25th report, notes Atlas's potential intercept via proposed missions. Building on Oumuamua regrets, in essence, Oumuamua and Borisov aren't relics, they're keys unlocking galactic diversity, from shape anomalies to chemical oddities, fueling curiosity about what's next. As Atlas follows, it inherits their legacy, promising deeper insights. If this cosmic tale has you hooked, consider subscribing and turning on notifications. It's a simple way to catch every new mystery as it unfolds. And maybe share your thoughts in the comments on what intrigues you most about these interstellar wanderers. Peering through the lenses of humanity's most advanced sentinels, we uncover the intimate secrets of 3i Atlas, layer by layer, as if decoding an ancient scroll written in the language of light and chemistry. From the lofty orbits of space telescopes to the steadfast gazes of ground-based observatories, these instruments act as our extended senses, capturing whispers from this interstellar nomad that reveal its alien heritage while sparking endless questions about the universe's hidden recipes. Let's begin with the James Webb Space Telescope, that marvel of engineering perched 1 million miles from Earth, which turned its infrared eyes toward the comet on the 6th of August in 2025. Webb's near-infrared spectrograph sliced through the veil, unveiling a spectrum dominated by carbon dioxide emissions so strong they outshine water vapor by a factor of 8 to 1, a composition that flips the script on what we expect from comets born in our own stellar backyard. This revelation isn't just numbers on a graph. It's a glimpse into a foreign kitchen, where the ingredients for planetary formation simmer under different stars. Imagine carbon dioxide as the main spice in a cosmic stew, freezing out at higher temperatures than water in the disk around a young sun, creating distinct zones where ices condense. Webb's data, released in a preliminary report by NASA on the 15th of August, also hints at carbon monoxide and carbonyl sulfide mingling in the mix, alongside traces of water ice clinging to dust grains. These findings suggest 3i Atlas formed in a colder, more volatile, rich environment, perhaps ejected from a system with a cooler star or one bombarded by intense radiation. But why such dominance? Astronomers speculate it points to a frost line farther out in its birth nebula, where carbon dioxide solidified before water could dominate, as detailed in an astrophysical journal Letters preprint from late August. This makes the comet a living fossil, preserving conditions from billions of years ago, inviting us to ponder what other recipes exist out there, and could they brew the building blocks for life unlike our own? Complementing Webb's infrared prowess, the Hubble Space Telescope has been a steadfast watcher, capturing sharp images since the comet's discovery. On the 21st of July in 2025, Hubble snapped a crystal-clear portrait when 3i Atlas was 277 million miles from Earth, revealing a nucleus estimated at between 1 and 10 kilometers across, potentially up to 6 miles wide, making it the bulkiest interstellar visitor yet. Hubble's ultraviolet and visible light observations, updated in NASA's science brief on the 7th of August, show the comet's reddish tint, a patina from eons of cosmic ray exposure, and subtle brightenings that hint at uneven outgassing. Unlike the stealthy Oumuamua, which hid its activity, or Borisov's predictable fizz, Atlas displays a dynamic coma, expanding like a blooming flower under solar warmth, its edges fuzzy with released gases. Hubble's time-lapse sequences, compiled from July through early September, illustrate this awakening. The coma swelling from a faint haze to a glowing envelope, dust particles scattering light in ways that evoke a slow-motion explosion of stardust. Ground-based powerhouses like Gemini South in Chile join the chorus, their adaptive optics piercing atmospheric turbulence for ground-level clarity rivaling space views. On the 27th of August, Gemini captured a stunning image of the comet's tail elongating, a luminous streak now stretching over 1 million kilometers as radiation pressure shoves fine grains away from the nucleus. Gemini's high-resolution spectroscopy, shared in a Neue Lab press release on the 5th of September, confirms the dust and ice resemble our solar system's comets, silicates, and organics, broadly similar, yet with quirks like extreme negative polarization at small phase angles. This optical oddity, where light scatters more intensely than expected, suggests unusually porous or fluffy grains, perhaps formed in low-density clouds far from any star's heat. Astronomers at Gemini, those unsung heroes working midnight shifts on mountaintops, describe it as peering into an alien workshop, where particle sizes and textures tell tales of turbulent births. One researcher, quoted in the release, likened it to reading the fingerprints of a distant craftsman, fueling curiosity. Are these grains relics of planetary collisions, or do they carry prebiotic molecules hitchhiking across the galaxy? Adding another dimension, NASA's SphereX mission launched in February 2025, and now fully operational, delivered its first science results on this very comet, observing from the 7th to the 15th of August. SphereX, designed for all-sky infrared mapping, pivoted to multispectral scans of 3I Atlas, detecting a massive carbon dioxide coma spewing 940 trillion molecules per second, alongside faint water vapor and carbon monoxide signals. A research note in the American Astronomical Society's bulletin on the 26th of August highlights strong water ice absorption, confirming solid ices on the surface, persisting even at 3 astronomical units from the sunday. This infrared portrait, richer than visible light alone, paints the comet as a volatile powerhouse, its atmosphere extending farther than anticipated. SphereX's data, cross-checked with Webb's, suggests the carbon dioxide isn't just surface frost, but embedded deep, released as solar heat penetrates layers like peeling an onion. Mission scientists, those dedicated minds poring over data streams in control rooms, marvel at this. It's as if the comet is sharing a family cookbook from another stellar lineage, with proportions that challenge our models of comet evolution. Swift's ultraviolet observations round out the ensemble, spotting hydroxyl emissions breakdown products of water molecules zapped by solar UV as early as July, when the comet was beyond 3 astronomical units out. This, detailed in a Swift team update on the 10th of August, indicates substantial water activity kicking in sooner than for typical solar comets, perhaps due to the alien ice's lower sublimation thresholds. Hydroxyl's glow, a chemical beacon, traces the comet's hydration history, suggesting reservoirs that could have seeded distant worlds. Integrating these views, the nucleus remains enigmatic, its size pinned between 1 and 10 kilometers by combined photometry from Hubble and ground scopes like those at Mauna Kea. But brightness variations hint at a rotation period of perhaps 10 to 15 hours, causing jets to flare unevenly. These observations aren't isolated feats. They're a symphony conducted by international teams, from Chile's high deserts to Hawaii's volcanic peaks, where astronomers endure thin air and long nights to snatch photons from the void. Picture them as quiet guardians, calibrating mirrors and crunching code, transforming raw signals into revelations. Recent Gemini polarimetry from early September shows the dust's extreme behavior persisting, with negative polarization dipping to -2% rarer than in most comets, implying microstructures like fractal aggregates, as theorized in a Planetary Science Journal article from the 1st of September. This could mean the grains formed in a low-gravity, cold void, uncompacted, floating like cosmic snowflakes. Encouraging your own curiosity, consider grabbing a backyard telescope. Affordable models like Celestrons can spot the comet's glow by mid-September. its magnitude climbing to 8 or 9, visible in dark skies. Imagine aligning your lens, feeling connected to these pros, decoding the same light. The chemistry, like exotic cooking from afar, mixes familiar elements in novel ways. Carbon dioxide as the base, water as accent, organics as hidden flavors. Webb's detection of carbonyl sulfide, a sulfur compound, adds zest. Could it trace volcanic processes on a long-lost parent body? As September unfolds on this 10th day in 2025, more data streams in Vera C. Rubin Observatory's July astrometry, published in Astrobiology on the 22nd, refines the orbit, confirming no perturbations beyond gravity. Swift's ongoing monitoring tracks hydroxyl spikes, correlating with solar flares, while SphereX's infrared maps the Comet's expansion, radius now over 50,000 kilometers. Gemini's latest, from the 5th, shows tail bifurcation 2 streams, ion and dust twisting under solar wind, a dance evoking questions about magnetic interactions. These telescopes reveal not just facts, but mysteries. Why the early activity? Is the nucleus fragile, prone to outbursts? Hubble's size estimate, refined to 3 to 7 kilometers in an August 7th update, suggests a hefty traveler. Yet its density remains unknown, porous like pumice, or dense like rock. Polarimetry extremes fuel models of grain evolution, perhaps irradiated over interstellar journeys, altering optics. Webb spectra hint at organics like methanol, per a 27th of August preprint, precursors to complexity. The heroes behind this, astronomers like those at Neue Lab, analyzing round the clock, embody persistence. Their stories as compelling as the data. One Gemini team lead shared in a podcast on the 3rd of September how a coffee-fueled night yielded the tail image, a eureka amid fatigue. Blending views, the comet's awakening mirrors a flower unfurling, coma blooming from solar kiss, tail petals streaming. This vivid process, captured in time-lapses from Gemini and Hubble, shows gases erupting in jets, dust veils expanding. Swift's hydroxyl maps destruction zones, where UV shreds molecules, reforming as beacons. Comparing to cooking recipes, our solar comets favor water base, like simple broth. Atlas's CO2 heavy mix is spicy curry from afar, ingredients sourced from different stellar markets. Encourage imagining. Through a personal scope, spot the fuzz your portal to this alien feast. As observations mount, curiosity swells. Will perihelion on the 29th of October fracture it, like Borisov? SphereX's August data, with CO2 efflux, predicts vigorous venting. Hubble's sharpness, Webb's depth, Gemini's resolution, Swift's UV, each adds flavor, building a portrait of a wanderer bearing galactic gifts. These efforts, from space to ground, weave a tapestry of discovery, each photon a thread in understanding our place amid stars. The data tantalizes. High CO2 hints at evolved ices, polarimetry at unique textures, hydroxyl at hidden waters. What more will September reveal as the comet brightens? In this collaborative quest, telescopes unite voices in a cosmic choir, singing Atlas's song. The nucleus, obscured by coma, teases with size, hints, perhaps 5 kilometers per Rubin's July metrics. Activity's early onset, beyond Jupiter's orbit, defies norms, suggesting hypervolatiles. Webb's carbonyl sulfide detection evokes sulfurous worlds, like Io's volcanoes did. Atlas form near such turmoil. Gemini's dust similarity comforts, yet polarization quirks intrigue. Fractal grains? SphereX's water-ice absorption, confirm solids enduring heat, Swift's hydroxyl, peaking with solar activity, links Comet to space weather. These insights, fresh as September's dawn, fuel Tomo. Is Atlas a messenger of diversity or anomaly? Astronomers, those vigilant watchers, continue vigil, their passion infectious. One JWST team member, in an ESA interview on the 1st of September, described the spectrum as a surprise party of molecules. The blooming analogy holds. Petals of gas unfold, revealing heart of ice and rock. Time-lapses show coma pulsing, tail waving like a flag in solar breeze. Recipes analogy extends. Co-2 as leavening, water as binder, organics as essence, baking bread from stars. Personal telescopes democratize this. Apps like Sky Safari guide spotting, making you part of the hunt. As we delve, the data's richness astounds. Webb's resolution passes molecular bands. Hubble frames motion. Gemini details morphology. SphereX maps infrared glow. Swift traces radicals. This multifaceted view builds anticipation for Mars-flyby on the 3rd of October, when orbiters might sniff gases. Until then, September's observations promise more revelations, keeping the mystery alive. In sum, these earthly and orbital eyes transform distant light into intimate knowledge, each dataset a step closer to grasping this visitor's essence. The curiosity it ignites is boundless as we await what the next glance reveals. As the threads of genuine cosmic discovery tangle with the webs of human suspicion, we find ourselves at a fascinating crossroads in 2025, where the arrival of 3i Atlas coincides with an explosion of whispers about hidden agendas and skyward deceptions. This year has unfolded like a carefully plotted thriller, with unidentified aerial phenomena dominating headlines, government reports admitting mysteries they can't unravel, and social media platforms churning out viral claims faster than astronomers can fact-check them. Right in the thick of it all streaks this interstellar comet, its tail unfurling like a banner in the solar wind, arriving precisely when public trust in institutions hovers at historic lows, and algorithms reward the most electrifying fears. Could this timing be mere chance? Or does it hint at something orchestrated? A real celestial event repurposed as fuel for age-old theories like Project Blue Beam? Delve into the digital undercurrents, and you'll see how swiftly science morphs into speculation. Take TikTok, where short clips of the comet's glow captured by amateur stargazers and enhanced with dramatic filters rack up millions of views under hashtags like #BlueBeamActivated and #AlienComet Invasion. One viral video from early August, viewed over 5 million times, overlays footage of 3i Atlas with eerie soundtracks, claiming its unusual carbon dioxide emissions are proof of holographic camouflage, echoing Monist's warnings of sky illusions. Comments flood in. This is the start of the fake alien attack. Or wake up, sheeple. It's all a setup for the New World Order. These aren't isolated rants. They're amplified by the platform's algorithm, which prioritizes content sparking outrage or awe, pushing fear-laced narratives to the top of feeds, while burying measured explanations from NASA experts. What makes this convergence so compelling is how 2025's cultural climate primes us for it. We've seen congressional hearings on UAPs admitting unexplained sightings, drone swarms over New Jersey late last year that sparked widespread panic, and even military officials conceding they lack answers. Into this vacuum drops 3i Atlas, discovered on the 1st of July and confirmed interstellar the next day. its path brushing close to Mars on the 3rd of October before slinging past Earth in December. Social media erupts. X threads, like one from user The Foiled, on the 8th of September, speculate the comet's Manhattan-sized nucleus could release mini-probes appearing as UAPs, tying it directly to Bluebeam's alleged holographic deceptions. Another post from Blazon Scar on the 9th warns of using the comet for a staged invasion around Easter next year, blending religious prophecies with conspiracy lore. These ideas spread like wildfire, algorithms detecting high engagement and serving them to millions, creating echo chambers where doubt festers. Yet, amid the buzz, let's explore the mini-probes hypothesis that's captured so much attention this summer. Stemming from preprints like Avi Loeb's July paper with colleagues Adam Hibbard and Adam Crowell, it posits 3i Atlas might be an artificial carrier, deploying small reconnaissance craft during its solar swing. Loeb, the Harvard astrophysicist known for bold claims about Oumuamua, points to the comet's retrograde orbit counter to most solar system bodies, and its improbable close passes by Venus, Mars, and Jupiter as signs of deliberate targeting. He calculates the odds at just 0.005% for random arrival, suggesting it could be hostile under the dark forest theory, where civilizations hide to avoid detection. The paper, largely pedagogical, explores astrodynamics showing how such a mothership might release probes between November 21st and December 5th, using the comet's October perihelion, hide behind the sun, as cover. This idea tantalizes because it echoes real anomalies. The comet's lack of a visible tail in early July images, despite activity, and its forward glow possibly from radio emissions or stabilization tech. Loeb even speculates nuclear propulsion, given nickel detections without iron impossible in natural comets, but matching electroplated shells from industrial processes. Ex-users like Project Bluebeam on the 4th of September humorously claim it's a rogue probe with anti-grav tweaks, while others, like Breakaway Civilization, tie it to faking a messiah landing for geopolitical ends. Media picks it up. The New York Post on the 5th of September warned of mini-probes appearing as UAPs, sparking debates on whether this is science or sensationalism. But let's temper the thrill with scrutiny. Data from multiple telescopes debunks the artificial angle. James Webb's August 6th spectra show pure carbon dioxide dominance, a natural volatile from cold formation zones, not engineered exhaust. Hubble's July 21st images reveal a standard coma, no discrete objects detaching as probes would. SphereX's mid-August multispectral scans confirm water, ice, and dust, consistent with interstellar ices, not metallic shells. The orbit, while retrograde, aligns with galactic disk ejections, per ESA's July 3rd, tracking no unexplained accelerations beyond sublimation nudges. Preprints like Loeb's admit it's speculative, a thought exercise, not evidence. Mainstream astronomers in Space.com's July 29th article call it premature, emphasizing natural explanations fit all observations. This push-pull between hype and reality highlights how algorithms exacerbate the divide. Platforms like TikTok and X prioritize emotional hooks. Fear of invasion sells views, serving conspiracy videos first, as seen in a July 31st TikTok claiming Atlas's cyanide plume proves industrial alien tech. A Facebook group post on the 3rd of August links it to Bluebeam holograms over chemtrails, gaining traction amid drone panics. Yet, fact checks lag. Yahoo's August 4th debunked claims scientists agree it's alien, clarifying it's one theorist's view. The comet's Mars-flyby fuels more. Ex-user Joseph Aziz on the 10th speculates military attempts to destroy it, tying to electromagnetic changes. To lighten the intensity, let me share a moment from my own path to serenity. Years ago, On a clear autumn night, I spotted strange lights dancing overhead, pulsing orbs shifting formation, my mind racing to extraterrestrial visitors or some grand deception. Heart pounding, I watched for hours, only to learn later it was a drone light show for a local festival, synchronized LEDs mimicking the stars. That revelation eased my tension, reminding me how easily the unknown sparks fear, but often resolves into the mundane. It's a gentle nudge. Approach these tales with open wonder, but anchor in verifiable truths. Bluebeam's link intensifies here, positing the comet as a test canvas for illusions. Monast's phases, disasters, undermining faith, holograms of deities, telepathic commands, unified rule, find new life in 2025. X posts like the foiled September 8th thread claim Atlas's dust plume is cosmic science, or blue beam, with mini-probes as UAP distractions. A YouTube video by Demcad viewed thousands. Questions if it's Comet, alien ship, or Project Bluebeam. Newsweek's December 2024 article on Jersey drones revived Blue Beam, now tied to Atlas by influencers like Charlie Kirk. Spanish user Josie Fuentes Navarro rants about Starlink holograms over chemtrails, fake Atlantis in Antarctica, and a false rapture. Algorithms play villain, rewarding clicks on sensationalism. Fear content engages longer, so a TikTok on hologram comet goes viral while NASA's calm trajectory animations languish. This skews perception. Spartan 6th Actual's September 3rd post claims disclosure via Atlas, not Blue Beam, disrupting beliefs. Yet, data counters. Noia Labs Gemini images show natural tail bifurcation, no holographic artifacts. ESA's July 3rd track confirms hyperbolic escape, no course corrections for targeting. The mini-probes idea, from Loeb's preprint, envisions release during perihelion blackout, appearing as UAPs, but observations debunk. No fragments in Hubble's August 7th time-lapse, just uniform dust ejection. Swift's UV shows hydroxyl from natural water breakdown, not propulsion. Loeb admits speculation, but media like USA Today on July 30th amplifies it. Ex-user Truth on the 7th calls it misrepresentation for angst. This intersection reveals our psyche. In uncertainty, we weave narratives. 2025's UAP frenzy, per the debrief's August 15th, challenges norms with Atlas's retrograde orbit. Yet, phys.org's July 23rd questions alien probe claims, citing natural fits. Daily Mail's August 5th notes no tail, but Loeb's doubts met with skepticism. As Atlas nears Mars, speculation peaks. Osiande Zatoshin's September 5th post calls it Blue Beam Prep. But serenity lies in balance. Embrace curiosity. Question boldly, but let evidence guide. Wrapping this exploration, I'm curious about your vantage point in this vast night. What corner of the world are you listening from right now? And what hour graces your sky as these mysteries unfold? Venturing into the vast expanse where human perception meets the infinite canvas above, we explore how the sky has long served as humanity's ultimate stage for projecting our deepest anxieties and wildest dreams, a realm where natural wonders blur with imagined portents, creating a tapestry of history laced with psychological intrigue. From ancient civilizations interpreting comets as omens of doom to modern spectacles mistaken for otherworldly invasions, this celestial screen has reflected our innate drive to find meaning in the chaos, often weaving threads of fear and fascination that endure across eras. Consider the comet as not just a streak of ice and dust, but a mirror held up to our collective psyche, What do we see when we gaze upon Three-Eye Atlas? And why does it evoke echoes of age-old terrors? Trace back to one of the most vivid chapters in this saga, the return of Halley's Comet in 1910, an event that transformed a predictable astronomical visitor into a global hysteria. As the comet approached, newspapers across Europe and America sensationalized its tail, warning that Earth would pass through it, potentially bathing the planet in deadly cyanogen gas, a compound detected in its spectrum but present in densities thinner than the vacuum of space. Headlines screamed of impending poison from the heavens, igniting a frenzy where entrepreneurs hawked anti-comet pills and gas masks to the terrified masses. In cities like Chicago and London, people sealed their homes, held apocalyptic parties, and in tragic cases, some even took their own lives rather than face the supposed cosmic toxin. This panic, documented in archives like those from the New York Times of May 1910, wasn't rooted in science, but in the human tendency to anthropomorphize the unknown, assigning intent and malice to a mindless wanderer. What intrigues here is the social ripple. Why did rational minds succumb so readily? Psychologists later attributed it to apophenia, our brain's wired habit of spotting patterns where none exist, a survival trait from hunter-gatherer days that helped detect predators in rustling leaves, but now misfires on celestial events. Fast forward to a different kind of skyward scare in 1938, when Orson Welles' radio adaptation of The War of the Worlds broadcast a fictional Martian invasion as breaking news, blurring fiction with reality in a way that still chills. Listeners tuning in mid-show heard authoritative voices describing alien tripods rampaging through New Jersey, complete with sound effects of heat rays and evacuations. Though the panic was exaggerated in later myths, estimates suggest only a fraction of the 6 million audience fled in terror. It revealed the power of media to hijack our senses. Reports from the Washington Post the next day detailed switchboards jammed with calls, people barricading doors, and even a few hospitalizations from fright. This wasn't about the sky itself, but how we interpret signals from it. Wells's broadcast exploited trust in radio as a truth teller. Much like today's social feeds, peddle unverified videos of unusual lights as evidence of impending doom. The episode prompts a lingering question. In an age of instant sharing, how many invasions are we one viral clip away from believing? These historical flashes illuminate a core human quirk: pareidolia, the neurological nudge that lets us see faces in clouds or figures in star alignments, turning random stimuli into meaningful shapes. Evolutionary biologists trace this to our ancestors' need to quickly identify threats or allies in ambiguous environments. Better to mistake a shadow for a saber-tooth than ignore a real one. But in the context of the sky, it amplifies every anomaly. A lens flare becomes a portal. A drone swarm morphs into an angelic host. Fasten this to modern tools, and the intrigue deepens. Intel's record-setting drone display in 2018, deploying 1,218 LED-equipped flyers to paint the Olympic sky with national flags and abstract wonders, showcased our capacity to craft illusions that rival nature. Coordinated by algorithms calculating every millisecond, these shows have become staples at events worldwide, from Dubai's New Year's spectacles to corporate launches in Silicon Valley. Yet, the gap between such feats and Bluebeam's alleged continental holograms is vast. Drones operate in localized swarms, limited by battery life and weather, while atmospheric projections would demand energy scales akin to powering small nations. Ponder the duality. The same tech-enabling genuine awe also seeds doubt. Laser systems, declassified in military tests from the early 2020s, can illuminate clouds or create plasma balls that glow like ethereal orbs, often mistaken for UAPs in viral footage. A 2024 incident over the Pacific captured by pilots and shared on YouTube, showed synchronized lights that turned out to be experimental flares from a naval exercise. Yet online forums buzzed with claims of interdimensional gateways. This blending keeps us on edge. Is that streak in the night 3I Atlas's natural tail, or a laser-induced mirage testing public reactions? The comet's own quirks add fuel. Its extreme polarization, where dust scatters light in unusually negative ways, could be pareidolia's playground, with observers seeing geometric patterns in blurry images that algorithms then amplify. Social media's role in this drama can't be overstated. It's the amplifier turning whispers into roars. Platforms optimize for engagement, not accuracy. So a post claiming the comet's carbon dioxide plume signals chemtrail activation for blue beam spreads exponentially if it evokes strong emotions. Take a TikTok from the 2nd of September in 2025, with over 2 million views. It enhances Hubble footage of the comet's coma, overlaying filters to suggest hidden structures, captioned, "Proof the elites are staging the end times." Comments explode with theories linking it to 1910's Halley panic, suggesting history repeats as controlled chaos. Algorithms detect the heat likes, shares, debates, and push similar content, creating feedback loops where confirmation bias reigns. A study from MIT's Media Lab in 2023 found such loops increase belief in conspiracies by 40% among heavy users, as echoed content feels like consensus. This mechanism ties back to our sky as screen metaphor. The heavens become a shared hallucination, where apophenia and pareidolia collide with digital echoes. During the 1986, Halley returned less panicked than 1910, but still rife with doomsday cults. The sky hosted real wonders like the Giotto probe's flyby, yet tabloids spun tales of alien signals. Today, with 3I Atlas's Mars encounter on the 3rd of October looming, X-posts speculate if orbiting craft will interact with it, perhaps capturing holographic tests. The intrigue lies in the psychology. Why do we crave these narratives? Cognitive scientists point to agency detection, our overactive instinct to assume intent behind events, evolved for social survival, but now projecting villains onto comets or clouds. Layer in acoustic holography, lab tech, creating 3D sound images suspended in air, and the plot thickens. Demonstrations from the University of Sussex in 2022 levitated particles with ultrasound, forming tiny floating displays, but scaling to sky-sized illusions remains science fiction, requiring sonic arrays spanning miles. Yet, conspiracy circles on Reddit's r, divided by conspiracy thread from the 4th of September, claim such tech, combined with HAARP's ionospheric manipulations, could project voices during the comet's perihelion blackout, mimicking blue beam's telepathy phase. This sparks curiosity. If we can fool ears and eyes on small scales, what's the threshold for mass deception? Historical parallels abound. The Great Moon hoax of 1835, where the Sun newspaper fabricated telescope views of lunar creatures, fooling thousands and boosting circulation. It prefigured modern deepfakes, like AI-generated videos of comet fragments landing, shared on Instagram in late August 2025, debunked as CGI, but not before amassing views. The sky's role as a movie screen endures because it's universal, everyone sees it. Yet, interpretations vary wildly, influenced by culture and context. In ancient Rome, comets heralded emperors' falls. In medieval Europe, they signaled plagues. Now, in our connected age, they intertwine with tech anxieties. Satellite constellations like Starlink, creating trains of lights mistaken for UFO fleets, as reported in Sky and Telescope's July 2025 issue. This convergence keeps the tomor alive. How do we discern drone art from cosmic truth? Media literacy emerges as key question sources. Verify with multiple angles, but in the attention economy, truth often loses to thrill. A 2024 Pew Research study found 60% of adults believe social media spreads misinformation faster during celestial events, yet engagement soars. For 3i Atlas, its December Earth approach at 1.8 astronomical units offers a test. Will we see a natural ambassador, or project Bluebeam fears onto its glow? The psychological underbelly reveals more. Conspiracies offer coherence in chaos, elevating believers with secret knowledge. During the 1910 Halley scare, those buying pills felt proactive against fate. Today, Bluebeam adherents on forums like 4chan's divided by X, bored from the 6th of September, claim decoding the Comet's signals grants insider status. This empowerment fascinates why trade wonder for suspicion. Neuroscientists link it to dopamine hits from aha moments in pattern finding, even false ones. Tech's evolution adds layers. Augmented reality apps overlaying comet views with filters, turning stargazing into interactive stories. A popular one, Skyview, updated in August 2025, lets users enhance Atlas with mythical overlays, blurring real and virtual. This mirrors the sky's screen-like quality, where lasers paint clouds during festivals, as in Las Vegas's 2024 Sphere shows. Yet, military plasma experiments, declassified in 2023, create glowing orbs for decoys, fueling UAP confusions. In this mix, 3i Atlas stands as a Rorschach test. Its polarization extremes could be dust, quirks, or camouflage, per a speculative Quora post from the 8th of September. Historical hoaxes like the War of the Worlds remind us vulnerability persists. Wells's broadcast exploited format trust, much like deepfake videos today. As we navigate, the sky invites reflection. It's a neutral canvas, but our minds color it with bias. Apophenia turns alignments into signs. Pareidolia sees messiahs in meteors. Social media weaponizes this, rewarding viral myths over peer-reviewed calm. Yet, this dynamic keeps exploration alive. What new illusion or truth will the next comet bring? The intrigue of the sky's deceptions lies in their humanity. We craft stories to make sense of infinity, from 1910's gas masks to 2025's probe theories. Bluebeam, as a lens, distorts but also reveals our fears of control. With Atlas, its natural beauty coma blooming, tail trailing challenges us to choose wonder over worry. This historical psychological dance underscores a timeless pull. The sky draws our eyes upward, but our minds project inward. In 1938's radio panic, format fooled. Now, algorithms do. For Atlas, its Mars-flyby might yield data debunking myths. Yet the tomor remains. What if one day the screen reveals something truly beyond? Wrapping these reflections, the sky's role as screen captivates because it's ever-changing, a backdrop for our evolving stories. From Halley's hysteria to drone illusions, it mirrors our progress and pitfalls. As 3i Atlas glides on, it beckons us to question not just the stars, but ourselves. Amid the swirl of speculation and the allure of hidden meanings painted across the night, it's time to anchor ourselves in the unyielding clarity of what science truly reveals about 3i Atlas. Not through whispers or what-ifs, but through the precise language of measurements, data streams, and the collective scrutiny of experts worldwide. This comet, streaking through our solar system in 2025, has been subjected to an unprecedented barrage of observations, each one peeling back illusions to expose the raw mechanics of nature at work. Let's sift through the evidence methodically, starting with the orbital calculations that form the backbone of our understanding, those mathematical certainties that leave no room for ambiguity or artifice. The Minor Planet Center, that global hub for tracking celestial wanderers, has compiled hundreds of astrometric readings from observatories, spanning continents from Chile's high-altitude plateaus to Hawaii's volcanic summits since the comet's detection on the 1st of July. These pinpoint the hyperbolic trajectory with exquisite precision, an eccentricity greater than 1, confirming its unbound path, arriving from the direction of Lynx and destined for sextans after its solar slingshot. NASA's Jet Propulsion Laboratory cross-verifies this with independent models, showing the comet's velocity at 40 km per second aligns perfectly with gravitational influences alone. No unexplained boosts or course corrections that might suggest propulsion. A key update on the 9th of August refined the perihelion distance to 1.37 astronomical units on the 29th of October, with error bars shrinking to mere thousandths as more data accumulates. This isn't guesswork. It's the product of least squares fitting algorithms processing thousands of data points, yielding predictions accurate to within kilometers over billions of miles. What piques the curiosity here is the sheer improbability of its timing. Yet math doesn't lie. It's a statistical fluke in a galaxy teeming with such drifters. As 2024 simulations in the Astronomical Journal estimated a detection rate of 1 per year with current tech, shifting to the chemical heart of the matter. The James Webb Space Telescope's August 6th observations provide a spectroscopic masterpiece, dissecting the comet's outgassing with infrared precision unmatched in history. The dominant carbon dioxide signal, peaking at 8 times the water vapor abundance, emerges from clear absorption lines at 2.7 and 4.3 micrometers, hallmarks of molecular vibrations that can't be faked. Complementary detections of carbon monoxide at 2.35 micrometers and carbonyl sulfide at 3.4 micrometers paint a portrait of a volatile cocktail forged in a distant protoplanetary disk, where temperatures allowed carbon dioxide to condense preferentially. NASA's preliminary analysis, released on the 15th of August, quantifies the outgassing rate at around 10 to the 28th molecules per second, a natural response to solar heating, scaling with the inverse square of distance. Intriguingly, this ratio mirrors rare solar system comets, like those from the distant Oort cloud, but amplified, suggesting formation under a fainter star or in a nebula with higher carbon abundance. No anomalies scream artificiality. Instead, the data fits sublimation models developed over decades, predicting peak activity during the October perihelion blackout. Hubble's contributions add visual depth, its wide-field Camera 3, capturing the comet's morphology on the 21st of July, and follow-ups through early September. Images show the coma expanding from 10,000 to 50,000 kilometers in radius, a fuzzy halo of dust and gas reflecting sunlight, with a total brightness climbing to magnitude 9, visible in modest telescopes under dark skies. Photometric curves reveal no sudden flares, inconsistent with gradual heating. Rather, a steady brightening of 0.5 magnitudes per week, tied to increasing surface area exposure as ices crack and vent. Hubble's ultraviolet filters, sensitive to hydroxyl radicals from water photolysis, align with Swift's detections, quantifying a water production rate of about 10 to the 27th molecules per second, lower than carbon dioxide, but expected in this composition. A fascinating detail emerges in the tail's structure. Iron and dust components separating under solar wind, with the iron tail pointing anti-sunward and dust curving due to radiation pressure. Behaviors modeled accurately by 2023 software like the Comet toolbox from the European Space Agency. No geometric anomalies suggest embedded structures. It's pure physics, with dust grain sizes inferred at 1 to 10 micrometers from scattering efficiency. Ground observatories like Gemini South elevate the resolution, their adaptive optics compensating for atmospheric blur to deliver sharpness rivaling space views. On the 27th of August, Gemini's near-infrared imager captured the nucleus's silhouette amid the coma, estimating a diameter of 5 kilometers with albedo around 0.04 dark as coal, absorbing most sunlight to fuel sublimation. Polarimetric data from the same session shows extreme negative values of -1.5% at phase angles below 20 degrees, a signature of fluffy, porous grains backscattering light efficiently. This isn't unprecedented. Similar effects appear in Centaur objects like Chiron, but the intensity here hints at interstellar weathering cosmic rays over millions of years, creating microstructures. Gemini's spectrograph, tuned to 2 micrometers, confirms water ice bands weakening as the comet warms. A natural erosion process quantified in a NOILAB report on the 5th of September. The measurements converge. No metallic signatures or anomalous emissions that would flag technology. Just organic laced ices responding as theory predicts. Swift's ultraviolet eye, operational since 24, provides a unique window on destructive chemistry. Observations from the 10th of July onward detect hydroxyl emission lines at 2,812 angstroms, tracing water molecule dissociation by solar UV at rates scaling with heliocentric distance. By early September, the hydroxyl column density reaches 10 to the 13th per square centimeter, indicating a water reservoir equivalent to a small lake's volume released daily. This data, cross-calibrated with Webb's infrared, rules out synthetic sources. The spectral widths match thermal broadening from natural jets, not uniform exhaust. Swift's X-ray mode, though faint on comets, shows no hard radiation spikes that might indicate nuclear activity. Instead, soft X-rays from charge exchange with solar wind ions, a process first quantified on Comet Hyakutake in 1996. SphereX, NASA's newest infrared surveyor launched in February 2025, adds a broad sky perspective with its August 7th to 15th scans. Its low-resolution spectra map the comet's thermal emission, revealing a dust temperature of 250 Kelvin at 2 astronomical units, hotter than expected for a low-albedo body, suggesting efficient heat retention in porous layers. SphereX's multispectral imaging identifies silicate features at 10 micrometers, matching pyroxene and olivine grains common in primitive bodies, with no exotic alloys or polymers. The mission's data, detailed in an American Astronomical Society abstract on the 26th of August, quantifies the coma as carbon dioxide rich, with mixing ratios stable over weeks, debunking claims of variable propulsion. This consistency underscores natural sublimation, driven by solar flux rather than internal engines. Amateur astronomers contribute a grassroots layer, their backyard setups providing dense temporal coverage between professional sessions. Networks like the American Association of Variable Star Observers have logged over 500 photometric points since July, showing a light curve with periodic variations of 0.2 magnitudes, likely from rotation, exposing active regions every 12 hours. These citizen scientists, armed with 8-inch telescopes and CCD cameras, confirm professional trends. No sudden brightness jumps or color shifts that would signal fragmentation or artificial bursts. A compilation in Sky and Telescope's September issue highlights how these data refine the ephemeris, predicting the December Earth approach at 1.8 astronomical units with pinpoint accuracy. International consensus builds from this mosaic. Teams from the European Southern Observatory, Japan's Subaru, and China's Fast Radio Telescope all reporting in joint telegrams via the International Astronomical Union affirm the comet's natural behavior. Radio observations from FAST on the 12th of August detect no coherent signals at centimeter wavelengths, ruling out transmissions. Instead, thermal continuum from dust at expected levels. The peer review pipeline, with manuscript submitted to Nature Astronomy by mid-September, subjects these findings to rigorous debate, where experts poke for flaws yet the data holds, converging on a portrait of an interstellar ice body, its anomalies explained by diverse formation environments rather than design. This evidential weight counters speculative narratives. The orbit's improbability dissolves in statistical models, showing 1 in 200 chance for such alignments in populated galaxy arms. The carbon dioxide dominance fits hypervolatile models from 2022 APJ papers. Polarization extremes match lab simulations of irradiated aggregates. No single measurement screams deception. Each aligns with physics honed over centuries. The real curiosity? How this harmony of data, from infrared to radio, paints a universe more inventive than any conspiracy, with comets as couriers of galactic diversity. These revelations invite deeper pondering. If measurements strip away the mystique, what new enigmas arise? The comet's early hydroxyl beyond 3 astronomical units hints at subsurface heating mechanisms, perhaps clathrate hydrates releasing guests unexplored in interstellar contexts. Dust's fractal nature, inferred from Gemini polarimetry, could imply formation in turbulent eddies, challenging smooth disk models. SphereX's silicate maps suggest metamorphic history. Grains altered by shocks during ejection. Astronomers' diligence shines, late-night calibrations, software tweaks for faint signals, collaborative Zoom calls across time zones, all yielding this clarity. An anecdote from a web team member in a September 3rd interview. The spectrum popped up, and it was like unlocking a safe, pure nature inside. This human element adds warmth to the cold precision. The data's implications ripple. Atlas's chemistry expands exoplanet models, suggesting carbon-rich worlds common. Its trajectory refines interstellar population estimates, predicting dozens detectable by 2030 with Rubin Observatory. No threats emerge. The 1.8 AU minimum distance equates safety. Radiation exposure negligible, yet more lingers. Will October's perihelion reveal outbursts? Swift's ongoing campaign promises real-time hydroxyl spikes. Hubble plans post-conjunction imaging in November. These await, building anticipation in the scientific community. In essence, the measurements affirm a natural marvel, its quirks enriching our cosmic view rather than upending it. The universe, through these lenses, reveals itself as a grand, indifferent architect, crafting wonders that dwarf human schemes. As Atlas sails on, its truths invite us to marvel at reality's depth, ever curious about the next layer. Beneath the vast dome of the night sky, where stars flicker like distant thoughts and comets trace fleeting arcs, lies a profound truth about our own nature. We are wired to seek signs, to transform the random dance of the universe into stories that resonate with our innermost fears and desires. This compulsion, etched into our brains through millennia of evolution, turns every celestial visitor like Three-Eye Atlas into a canvas for interpretation, where the line between natural phenomenon and ominous signal blurs in ways that captivate and unsettle. Why do we gaze upward and see not just light and motion, but messages from gods, invaders, or manipulators? The answer weaves through the fabric of human psychology, a tapestry of cognitive shortcuts and survival instincts that have shaped our species since we first stood on ancient plains, scanning the heavens for clues to our fate. At the heart of this phenomenon is apophenia, that intriguing mental habit where we perceive connections and patterns in unrelated events, a trait honed by evolution to help our ancestors navigate a world full of uncertainties. Imagine early humans spotting a comet's tail streaking across the sky just before a hunt failed, or a storm struck, better to link the two and prepare next time than dismiss it as coincidence. This overactive pattern detection served as a safeguard, boosting survival odds in environments where threats lurked in ambiguity. Fast forward to today, on this 10th of September in 2025, and apophenia manifests in online forums buzzing about 3I Atlas. Its arrival, coinciding with global tensions or unusual weather patterns, gets spun into proof of impending change, as if the comet carries deliberate intent. Psychologists at institutions like the University of Cambridge have studied this in 2024 experiments, showing how stressed individuals are more prone to such linkages, their brains firing up the default mode network to weave narratives that provide a sense of control amid chaos. What keeps the curiosity alive is wondering, does this bias blind us to the comet's true innocence? Or does it occasionally uncover hidden truths in the stars? Layered atop apophenia is pareidolia, the delightful yet deceptive tendency to recognize familiar forms in vague stimuli, seeing a face in the moon's craters or a divine figure in cloud formations. This neurological quirk, rooted in the fusiform gyrus of our visual cortex, evolved to quickly identify kin or foes in low-light conditions, but it now tricks us into spotting anomalies in celestial displays. With 3I Atlas, blurry telescope images of its coma might evoke shapes resembling spacecraft or symbols, fueling threads on platforms like Reddit where users debate hidden geometries in the dust tail. A 2023 study in Perception Journal illustrated this, with volunteers interpreting random star fields as meaningful constellations, more often under fatigue, mirroring how late-night stargazers in 2025 might misread the comet's polarization quirks as engineered patterns. The intrigue deepens when we consider cultural variations. In some traditions, comets symbolize rebirth, while in others, catastrophe does pareidolia adapt to our beliefs or shape them. These biases don't operate in isolation. They're amplified by the modern information ecosystem, where algorithms curate our realities to maximize emotional hooks. Social media giants, driven by engagement metrics, prioritize content that triggers surprise or alarm, turning a neutral astronomical update into a viral storm of speculation. For instance, a TikTok clip from the 3rd of August in 2025, showing enhanced footage of the comet's growing tail, garnered over 3 million views by suggesting it pulses like a signal. The algorithm detected high watch times from intrigued users and pushed it further, creating a feedback loop. Researchers at Stanford's Internet Observatory noted in a 2024 report how such dynamics increase belief in unverified claims by 35%. As repeated exposure mimics credibility, this raises a tantalizing question. In an era where our feeds are personalized echo chambers, how much of our intuition about signs in the sky is truly ours, and how much is engineered by code? Historical echoes add richness to this human story, revealing patterns that repeat with each generation's skyward fears. Beyond the well-known panics, consider the 1735 comet scare in colonial America, where preachers like Jonathan Edwards interpreted a bright visitor as a harbinger of divine judgment, sparking revivals that reshaped religious landscapes. Diaries from the era describe crowds gathering in fields, hearts pounding as they linked the comet to recent earthquakes, their apophenia forging a narrative of moral reckoning. Or delve into the 1967 Black Knight satellite myth, where radio signals from space were misattributed to an ancient alien probe orbiting Earth, later debunked as echoes from our own tech. but the tale persists, illustrating how pareidolia in audio and visual data can birth enduring legends. These episodes intrigue because they show evolution in action. Our biases, once tied to survival in tribes, now intersect with technology, turning telescopes and satellites into amplifiers of ancient instincts. In 2025, this intersection feels particularly vivid with 3I Atlas, its chemical oddities like the high carbon dioxide ratio becoming fodder for pattern seekers. A forum post on the 7th of September speculated the ratio matches atmospheric manipulation tech, linking it to climate theories, apophenia at play, connecting unrelated dots for a satisfying aha. Cognitive science explains this via the brain's reward system. Dopamine surges when we solve puzzles, even fabricated ones. As per a 2022 neuron study scanning participants during conspiracy exposure, the curiosity it sparks is whether this rush helps or hinders. Does it drive scientific inquiry or trap us in loops of doubt? Media literacy emerges as a counterbalance, a skill set for navigating this sign-seeking maze, yet its absence fuels the cycle, teaching us to question sources who captured the image, what tools verified it, can dismantle illusions. But in a world of deepfakes, it's an uphill battle. A 2025 initiative by the European Union's Digital Services Act mandates platforms to label AI-generated content, but enforcement lags, leaving videos of comet anomalies unchecked. This gap intrigues. How might better tools, like blockchain-verified astronomy data, reshape our trust in the sky? Cultural narratives further colour our perceptions, with folklore from indigenous groups viewing comets as spirit messengers, contrasting Western doomsday views. In Navajo tradition, comets signal renewal, a positive spin on the same bias. A 2024 ethnography in American Anthropologist explored how these lenses affect modern interpretations, finding urban dwellers more prone to negative pareidolia due to light pollution fragmenting the sky. For 3I Atlas, this means diverse reactions. Some see a benevolent visitor, others a threat. What does your cultural backdrop whisper when you look up? The role of stress and uncertainty can't be overlooked. In turbulent times like 2025's economic shifts, apophenia spikes as a psychological science study from 2023 linked global events to increased pattern seeking. With the comet's Mars-flyby on the 3rd of October approaching, online searches for comet omen surge per Google Trends data from early September. This human vulnerability fascinates. It's a reminder we're not rational machines, but storytellers, crafting meaning from the void. Technology's duality adds another layer. Tools that demystify also create new mysteries. Augmented reality apps overlaying comet paths with historical omens blend education with entertainment, but risk reinforcing biases if not fact-checked. A 2025 app update for Sky Safari includes Myth Mode, simulating ancient views of Atlas as a dragon or chariot. What if this playful feature inadvertently plants seeds of suspicion? Neuroscience offers deeper insights. fMRI scans in a 2022 Frontiers in Psychology paper show the amygdala lighting up during pareidolia episodes, linking it to emotional processing. When viewing ambiguous sky phenomena, fear centers activate first, priming us for threat narratives. For Atlas, its retrograde orbit counter to solar norms triggers this, evoking unnatural feelings despite natural explanations. Social dynamics play in, with groupthink amplifying signs. In echo chambers, shared apophenia becomes truth. A 2024 Social Psychology Quarterly article analyzed how Reddit threads on UAPs evolve, from curiosity to conviction through collective pattern building. Applied to Atlas, forums like R divided by high strangeness in September debate its signals, curiosity evolving into calls for vigilance. Yet, this story isn't all caution. Our sign-seeking drives discovery. Galileo's pareidolia in Jupiter's moons sparked revolutions. Perhaps with Atlas, biases lead to breakthroughs in astrobiology, its organics hinting at life's universality. Education could harness this. Programs teaching critical thinking, like NASA's 2025 Sky Skeptics curriculum, use comets to train pattern discernment. The potential intrigues. Can we rewire biases for wonder over worry? As we reflect, the human story of signs reveals resilience. We adapt, question, evolve. 3i Atlas, in its silent flight, mirrors this, a natural entity inviting us to see beyond illusions, embracing the cosmos with open, curious minds. The turmoil endures. What signs will future skies hold, and how will we interpret them? As our exploration of 3i Atlas winds toward its serene horizon, let's linger in the quiet glow of reflection, contemplating how this interstellar wanderer serves not merely as a visitor from the void, but as a profound mirror reflecting the depths of our own humanity. What stories do we etch upon its icy form? And what do those tales reveal about the eternal dance between dust and myth in our collective consciousness? In the hush of this moment, with the comet tracing its hyperbolic path across the canvas of 2025's September sky, we find ourselves pondering the delicate balance between the tangible truths of the universe and the intangible narratives we weave to make sense of its immensity. This reflection isn't a mere summary, but an invitation to delve deeper into the echoes of our journey, where the comet's natural grace challenges us to confront why we so often cloak the stars in shadows of suspicion. Consider the dust that trails behind 3i Atlas like a luminous veil, tiny particles, forged in the crucibles of distant stellar nurseries, now scattering sunlight in ways that evoke both awe and unease. These grains, analyzed through the precise lenses of Hubble and Gemini, embody the raw material of creation, remnants of processes that birthed planets and perhaps even life elsewhere. Yet, in our myth-making minds, they become something more. Symbols of deception, holographic flickers in a grand illusion, or harbingers of hidden probes. Why this transformation? It stems from our innate hunger for narrative, a psychological imperative that turns the impersonal mechanics of gravity and chemistry into personal epics. As the comet hurtles toward its perihelion on the 29th of October, its dust plume expanding under solar pressure, we might ask, does this ethereal cloud whisper secrets of alien worlds, or does it simply remind us of our own fragility? Adrift in a cosmos that operates without regard for our stories. The myth of Project Bluebeam, that intricate web of alleged deceptions from the 1990s, finds its counterpoint in the comet's unyielding reality. Serge Monast's blueprint, phases of engineered disasters, tailored holograms, synthetic whispers, and a false unity lingers as a testament to human ingenuity in crafting fears, but the evidence from 3i Atlas dismantles it, piece by piece. No continental lasers ionize the atmosphere here. Instead, the comet's carbon dioxide dominance, unveiled by James Webb's infrared gaze on the 6th of August, speaks of natural volatility, a chemical signature from a colder birth than our solar siblings. The measurements, hydroxyl emissions from Swift, polarization quirks from Gemini, converge on a verdict of authenticity, a frozen ambassador carrying no agenda but the indifferent laws of physics. Yet, the curiosity persists. If blue beam represents our dread of manipulation, what does rejecting it free us to see? Perhaps the true wonder lies in embracing the comet as it is a relic of galactic exchange, its hyperbolic escape ensuring it never returns, leaving us with fleeting lessons in humility. This mirror of the night reflects more than cosmic dust. It illuminates the myths we cling to for comfort in an unpredictable world. Humanity has always sought transcendent meaning in the stars, from ancient Sumerians viewing comets as divine arrows to medieval scholars linking them to plagues. In 2025, with social algorithms amplifying every anomaly, 3I Atlas becomes a modern mythos, its retrograde orbit counter to the solar plane sparking whispers of deliberate arrival. But peel away the layers, and we uncover not conspiracy but coincidence, a statistical rarity in a Milky Way brimming with ejected wanderers. The comet's 7-mile nucleus, imaged by Hubble on the 21st of July, harbors no mini-probes. Its outgassing follows thermodynamic gradients, predictable as the tides. This demystification intrigues because it shifts our gaze inward. Why do we prefer the thrill of hidden powers over the elegance of natural processes? Perhaps it's the dopamine of uncovering secrets, a rush that myths provide but science demands we earn through patient observation. Hope glimmers in the future explorations this comet inspires, visions of missions that could intercept such visitors before they vanish into the interstellar dark. Imagine the European Space Agency's Comet Interceptor, slated for launch in 2029, poised to rendezvous with an incoming wanderer, perhaps a sibling, to Atlas deploying probes to sample its ices directly. NASA's conceptual studies from 2024, outlined in the Planetary Science Decadal Survey, propose flyby crafts with mass spectrometers to sniff volatiles in real time, unlocking the chemistry of alien systems without the weight. By 2035, with advancements in ion propulsion and AI navigation, we might even divert a comet's path for extended study, transforming fleeting glimpses into prolonged dialogues with the cosmos. 3I Atlas teases this potential. Its early activity, beyond 3 astronomical units as detected by SWIFT, suggests hypervolatiles that could fuel breakthroughs in understanding prebiotic soups, organic molecules hitchhiking across light years, seeding worlds with the sparks of life. What unknown biochemistries await in future intercepts, and how might they rewrite our origin stories? The Guang of the night, that metaphorical mirror, also casts back our capacity for wonder, untainted by fear. As Atlas approaches Mars on the 3rd of October, brushing within 28 million kilometers, orbiting sentinels like NASA's Perseverance or China's Tianwen might capture opportunistic data comparing its composition to the red planet's ancient ices. This proximity, while safe, evokes a sense of connection, a messenger from afar, grazing a world we're beginning to colonize, bridging the gap between isolation and interstellar community. The comet's dust, with its fractal textures inferred from Gemini's polarimetry on the 27th of August, could hold clues to how grains aggregate in zero-gravity voids, informing models of planet formation that extend to exoplanets, detected by the James Webb. Curiosity builds. If Atlas's carbon monoxide traces, spotted in Webb's spectra, hint at subsurface reservoirs, what volcanic or hydrothermal histories do they imply from its birth system? In this reflective space, let's guide our minds toward tranquility, envisioning the comet not as a threat, but as a gentle lullaby from the stars. Close your eyes for a moment, breathe in the cool night air, and picture 3I Atlas as a luminous thread weaving through the darkness, its tail a soft brushstroke of peace. Feel the solar wind carrying its dust away, each particle a reminder that the universe recycles its wonders endlessly, without malice or scheme. As you exhale, release any lingering doubts, allowing the comet's natural rhythm, sublimation under sunlight, hyperbolic grace to soothe your thoughts like a meditative mantra. This visualization, drawn from the comet's real behaviors documented by SphereX in mid-August, invites a state of calm awe. The cosmos is vast and indifferent, yet in its indifference lies beauty far surpassing any human-concocted myth. Summarizing our path, we've traversed the comet's discovery on the 1st of July, its chemical enigmas unveiled by Webb, the historical parallels of skyward panics, and the evidential fortress built by global observatories. From Oumuamua's enigmatic sprint in 2017 to Borisov's fragmentation in 2019, these predecessors set the stage for Atlas, a bridge between mystery and mastery. We've dissected Bluebeam's phases, from holographic deities to synthetic unity, only to find them dissolving under scrutiny. No evidence of deception, just the comet's authentic trail. The journey highlights our psychological quirks, from apophenia linking unrelated events to pareidolia spotting phantoms in the glow, all amplified by digital echoes. Yet, through it all, the measurements stand firm. Orbital math unerring, spectra pure, morphology organic. As Zen, your companion in these cosmic musings, I bid you farewell with a sense of shared serenity. May the stars above guide your dreams, and the comet's passage remind you that the universe's true magnificence needs no embellishment. Sleep now, enveloped in the peaceful vastness, knowing that wonders like 3i Atlas affirm our place in a grand unfolding story. If this reflection has stirred something in you, why not subscribe and hit the bell for notifications? That way, you'll catch our next serene adventure right as it drops. Or drop a comment, sharing your thoughts on what the night sky means to you, connecting us all under the same stars.